Right, so here we have two different objects of masses 3m and 4m are placed with their centers 15 meters apart, and it exerts gravitational force of 7.5 times 10 to the negative 4 newtons on each other. And it wants us to calculate the mass of the 3m object. So I'd like to point out here, the mass is not given to you in kilograms, it's just given to you in terms of variable. Here is 3 capital M and then 4 capital M. We don't know what M is, so we got to figure it out, okay? So here's a visual for you. In no particular order, I just went from left to right. I just put the 3m mass on the left side and the 4m mass on the right side. If you want, you can put the 4m on the left side and the 3m on the right side. The gravitational force here is opposite but equal in magnitude, and the magnitude is given here as 7.5 times 10 to the negative 4 newtons. So I want to point out that these two arrows are the same length. They just happen to be pointing in opposite direction based on the perspective that you're looking at, okay? So we would say M3 is attracted to 4M, and we would say M4 is attracted to 3M. The distance here between their centers is given in the statement as 15 meters. All right, so let's crank it up. In order to do this one, we're given gravitational force, which is 7.5 times 10 to the negative 4 newtons. So hopefully that triggers that you need to apply Newton's gravitational law, which is F, which is equal to the capital G, Newton's gravitational constant, times mass 1, mass 2, divided by x squared, x being the distance from center to center. Here, I'm just going to apply it. Okay, so I'm just going to carry this function over. F is right there. Capital G is universal constant. I'll keep that as capital G for now. I don't know what M1 is. I'm just going to call M1 3 capital M, whatever it is. And then I want to separate that from M2, and M2 I'm just going to call 4 capital M because the diagram says 3M and 4M. All right, and then I'm going to divide it by x squared. So therefore, I'm just going to simplify this really quick. 3M times 4M is 12M squared. 3 times 4 is 12. M times M is M squared. So all I did was I simplify the numerator a little bit. Here, the only thing that I don't know is M. I need to solve M. Once I know M, I can multiply M by 3 because that's the mass of the object that it wants. It wants the mass of the 3M object. I don't know what M is, so really ultimately here, I'm just trying to find what M is, okay? To get M squared by itself, the next algebra step would be to get rid of this x squared in the denominator. To do so, multiply both sides by x squared. So you notice here now there's an x squared on the left side, or you can just bring the x squared up to the left side if your algebra is good. And then here, m squared is still not by itself. You have a capital G, you have the 12. So I'm going to divide both sides by G and 12. So that's going to look like this. So now I have m squared is equal to x squared times f divided by 12 times G. I just wrote the 12 out in the front here. If you want, you can keep G in the front and 12 behind. I just like my coefficient in the front. All right, here, if you read the problem with me, x is given as 15, force is given as 7.5 times 10 to the negative 4 newtons. G, we already know. So everything is already know, or everything's already given. Here I'm just going to go ahead and solve for m by taking the square root. This is m squared. So in order to get m by itself, we square root both sides. Square root on the right side, we just leave you with m. And then the radical here of the left side looks a little messy, but it's not too bad. So here I just plug in x is 15. There's the square. Force is given as 7.5 times 10 to the negative 4. And then here's the 12, and here's the g value. This is negative 11. Okay, so I want to point out, make sure you, when you do the universal constant, that this is negative 11. I've seen mistake made where it's positive 11. So that is a negative 11. All right, I'm just going to simplify the numerator one at a time for you. So if you struggle with calculator work because of scientific notation and the usage of parentheses, I highly encourage you just do the numerator and then do the denominator separately and then divide, okay? So here, if you punch all this stuff in, 15 squares 225 times 7.5 times 10 to the negative 4 will give you 0.16875. And then 12 times 6.67 times 10 to the negative 11 will give you 8.004 times 10 to the negative 11, negative 10 on the bottom here. Now, you have two numbers. All you have to do is plug these two numbers in to your calculator, and you'll get... Don't mind the units. I just cancel everything out there for you if you need to. But units will cancel out naturally if your algebra is good. Okay. So if you take 0.16875 divided by 8.004 times 10 to the negative 10, you'll get 2.11 times 10 to the 8th. And then the square root of that is going to be 14,491 kilograms. I want to point out that you're not done yet here, right? You just found what m is. So you can't stop here. The question asks you calculate the mass of the 3m object. Well, you just found m, so to find the mass at 3m is super light work. Just carry it down. Here's the left mass that I just called 3m. Oh, here's the 3. I know what m is. I just calculated. M is 14,491 kilograms. So 3 times 14,491 will give me 43,473 kilograms. And that's it. Okay. If it asks for the 4m, you would do the same step, right? So instead of 3, you would just do 4 times the mass that you just calculated. Okay. All right. I hope that helps. Stay nerdy. Don't be wired.